For our presentation and project, we worked on comparing private and public universities and the information that we know. And I'm Faraz, and I work with Mohammed and Haru. And our advisor was Professor Dr. Elena Brainova. So for our data set, we got this data set online from this website called Kaggle. And this data set is updated for the year 2020, which was when we started working on the project. And different information that this data has is it includes acceptance rate, enrollment, and graduation rate for both private and public universities. And so some info about the data set. There's a total of 18 attributes, and one of them is nominal, and 17 of them are numerical. And there's a total of 777 instances, and in the data set, there's 0 missing values. So some different information about the attributes. There's different attributes such as private, which tell if it's a private or public universities. There's accept, which says the number of applications that were accepted. There's enroll, which says the number of new students enrolls. There's top 25 percentage, which represents the number of new students from the top 25% of high school class. And there's outstate, which represent out-of-state tuition. Also, a few more attributes where there's books, which are the estimated books cost. There's PhD, which represents the number of faculty with PhDs. There's grad rate, which represents the graduation rate of these students. So before we started working with our data, we found our data was in a CSV format. So we had an issue converting this into WHATDO, which was the application program we were using. And so to fix this problem, we had to first change the data format in Excel before we loaded it into WHATDO. And for R, the problem we were having was it was in another directory. So we had to move the data file that was in CSV format for R into the correct R directory. And then once we did this, then we were able to load the data into R. Before conducting our investigation with the data was how does enrollment depend on the number of applications and whether it is harder to get into a private or public university. And also we wanted to ask how does graduation rate depend on the acceptance rate. And another question that we had was can we predict the type of university based on the acceptance rate, graduation rate, enrollment, and how different private and public universities are.
So we used a box plot to compare the acceptance rates of public universities compared to private universities. The graph shows that the acceptance rate for public universities is higher, but there are a couple outliers. The most noticeable outlier for private universities show that there is a select few private universities that have a higher than normal acceptance rate compared to others. The outlier of the public universities show that there are a few public universities with a high acceptance rate, and the one all the way to the right represents a public university with an extremely high acceptance rate. So this bar graph compares the graduation rate of public versus private universities. This chart shows that there is a much higher total amount of people that graduate from private universities. A possible conclusion from this is that people attending private universities are more dedicated to finishing their degree. So in this graph, we use a scatter plot to compare how many people are enrolled in a university versus how many people end up graduating for both public and private universities. The graph shows that for the most part, universities have an enrollment rate of 500 or lower. These universities' graduation rates are varied. We can see that universities with high enrollment generally have a high graduation rate as well. This graph shows the correlation between the application rates and the acceptance rates for both public and private universities. The scatter plot shows that most universities accept only half of the applications that they receive. We can see that overall, the university's application to acceptance rate is proportional, meaning as the amount of applications get higher, so does the acceptance rate. The single top right dot represents a university that has about 50,000 applications and only about 25,000 acceptances. So this graph shows an overall summary of the data. We chose to represent attributes that would give the most information about the universities. And the results are what you would expect. Out of everything, universities receive the applications the most, followed by acceptances. The amount of people that end up enrolling is less than acceptances. The attribute all the way to the right is the graduation rate, which is the lowest out of all the attributes. Here we can see that there's only one non-numeric attribute, which is the very first one, private, and the rest are numerical. We can see the 5 number statistics for the 17 numerical attributes.
For the model we use the tree model for J48, random tree, random forest, decision stump, and LMT. For the rules model, we use the 1R part and the 0R JRIP. For possibility models, we use the Navy base. Classification results. The random forest LMT tree algorithms with a 66 split were the most accurate with 94.31%. J48 tree was also accurate with 92.42%. The JRIP with a 66 split was the most accurate with 92%. Part algorithm with 66 split was also accurate with 91%. Navy base with a 66 split has an accuracy of 89%. So the part of the rule 66 split, it shows different attributes and compare different attributes, make predictions, shows high accuracy. The decision tree J48 66 split compares different attributes, predictions, percentage. It was easier to understand and look at this. The decision tree and the random tree 66 split, they are compare a lot of attributes or accuracy to make predictions.
Yeah, so overall, what we found was that the graduation rate is higher in universities that have a higher enrollment rate. And so we use different visualization techniques to better understand the relationship between the attributes such as applications, acceptance, enrollment, and graduation for both types of universities, and we were able to compare them together. And what we were trying to do was predict whether the institution type we saw was public and private were distinct, and how the constructed classifiers have a very high accuracy, and also how constructed classification rules as well as decision trees can be used to describe the differences between private and public universities. Thank you all for listening.